So now you have these included. So if you were to add a new function to the hxx, so for example, I had written a traverse and print function, this one over here. If I want to add this function to the hxx, I'll just copy this one.
Hey, how you doing? I don't know, I was trying to make an appointment with you. When would be a good time for you to come in? Oh, okay, let me call you back.
Right before the iterator functions, just paste
Stay
it.
here at 7 o'clock.
So
Today is,
this is how I add a new function to
today's
the
Tuesday.
class,
Well, you know what, let me
but
call
I
you
also
back.
need to add
You know, pick your daughter and all that.
the
and then
header
I'll call you back, or you can call me back and then we can figure something
to
out.
the HPP.
All right, talk to you soon. Bye.
I'll just add it here. So there we go. Now we're all set to be able to use this function inside the main. So I can just call the traverse function.
No, it was only social security or income under 4,150, then you would be able to.
So this is the new function that I'm able to call with the object of the class, and I can run it. So as you can see, first I'm just trying to use the for loop to iterate and use the iterators. In the traverse function, I'm using the pointers to iterate, to run over it. But the traverse function is printing it just fine.
It actually won't either because she doesn't have a custom pay.
Now, if I were to change anything inside over here, so for example, I can actually, add more nodes. So you can always use this function to test any of the function that you use this main program to test any function that you're writing. You can call several appends and prepends, but if I'm just calling append successively, now my list would have, those new items also in the list. So I can again traverse over it and run it to see that this is my list created. So the point for the homework 4 is that just how I'm able to write this traverse function that I demonstrated last week also, how I'm writing a traverse function, this is what it wants you to do, to write a frequent function where where it takes in an argument element and it finds out what is the frequency of that element in the list is. And if the item is not found in the list, or if the list is empty, then return 0. What that means is if you were to write a function on this list and call that function for 13, it should return 3. That's the goal of the function. Then we also saw in a similar way, not the exact same way, but in a similar way, how to also write and add a function to the delinked list class. And we had written a couple of functions for the delinked also that I just walked through in the last week. So you have the traverse and print function. Then you also have the print reverse function. These we can write based on the logic, but we have to follow that they are naming their items correctly. But we are also able to put them in a SLL project to see that actually it's fitting in the class and producing the correct result. So that's what you have to do for both of them, the 5 and 6 questions. One for the SLL, the other for the DLL. So then mostly you should, the goal is like try to figure out the logic and then try to write the function completely and add that function into the HXX, the header in the HPP, and then try and run it on the example main program to see for several different items to see if it is running properly. So to get some practice on something similar to this, I mean, I will give you some example questions right now and then not the homework questions, but some other functions, but with some goal. Once you get some practice, like we have seen traverse functions and those you have on the titanium also, and I went over the last week. And now you have a chance to work with your group members to figure out the answer. And then that will give you some idea on how to approach the homework problems. Okay. And so this is just a class activity where you're working in a group, but for the homework, you should just work individually. But here are the questions. So we have Derek. Derek can just be a part of any group, but maybe he will not like help you, but he can just like be there in the group if he likes. And then we are mostly your 11 students in the class. And so how many groups? Let me see if we have so 4 people in a group, probably 3 groups should be good. 3 groups. And then let's do one thing. I'll be posting the question in the chat. So based on the breakout room number, once I'm breaking you out in the room numbers, always just remember to record your room number. So you will see which room you're going into. And that question that I'm posting in the chat is relevant to the room number. So you have different questions that each breakout room will try to solve. Okay, so here are the questions I'm posting in the chat.
Kind of busy, I guess. Hey, did your daughter Yelena, did she attend school last year?
You can just copy these questions from the chat that I've just posted over here.
Okay.
Copy these questions somewhere and then just paste them somewhere on your any text editor on your own computer.
Right. Yeah, okay.
And once I break you out in the room, just remember to remember your room number and whichever room. So for example, if you go to room 2, then take the question that is given for the room number 2 and just figure out, discuss how would you like to solve the question, and then mostly anyone can volunteer from the group and try to share their screen if you have the code ready, or whatever situation, whatever step your code is in, you can just post it in the chat after you come back. This activity is not graded. You don't have to be correct. Don't worry about being wrong. You're just trying to learn. So it's 5:47 right now. So I'll give you until maybe. Okay, so do you have any questions before that?
Do you know how much you made, or?
Is there like a template code you want us to use for this?
Yes, so the template is right here. So for example, this is the singly linked
And
list
just check
project,
to see
right?
if you have that.
This is
It's
what
really
I just
important. You'll get
demonstrated how
back
to
you this year.
create
It'll
an
set the
SLL
point
example
that
project.
it'll
Just
monitor.
creating an
So
SLL
gotta
example
figure out what
project,
we're gonna do. If
have
you
the
could-
main
if
function, you
could
can
see-
take the main
'cause I looked
function
and I only have the
from
2 pages. They're, white
this one over
and
here.
blue
This is
and
the
gold
S-linked list
lines.
example that gives you the main function.
There's no figures on it.
Then I'm hoping everyone has the GitHub code downloaded to their computers. It doesn't take time at all, right?
Yeah.
You just have to
Yeah,
go to
you
the
could
GitHub.
email, you could fax it, either one, you know, 'cause
There
it's
is
a
a
lot
source
of
code.
work for you to come down. So, you know, all I just
Click
need
on
is
the
quick,
code
I can get that.
and then just click download zip.
And I can call you, we can make an appointment.
And from there, you should be able to, like we did over here,
Yeah, I do have the
go
mortgage
to the
statement.
GitHub
I have the
master
mortgage
folder,
statement,
wherever
I
you
have your-
download it,
your W-2.
and get the, so
I have,
depending on the group, if you got the work for the S-link list, then you have to get these two HPPs. Simply copy from the master folder and bring it to the current whichever example project you're working in, paste it over here, just like I did. Then you have to attach them, the header files. This is something that you can do before even, I mean, like, that's fine if you're not able to complete everything. I mean, just you have some code that you have figured out, and then we'll all improve upon it. So if you want to have the time to run it, this is what I'm showing over here, that attach the files over here. And then once the code you have written, just supposing the task was to write the traverse function itself, and you were able to write this function since you have the logic for it, then you can just like put this function over here and then call it in the main function, main program, to see if it is working correctly.
Did they give you that form?
So how much time do you think you may need for this function? So probably is 20 minutes enough?
Form that usually has all the names of all the people that are covered under the insurance.
20 minutes enough?
Oh yeah.
20 to 25, maybe.
Yeah, okay, 25 minutes is good.
All right.
So let me give you till we are about 5:50 p.m. So let's meet again at 6:15 p.m. Okay? And the assignment to the groups is just random. There is no prior way how I'm choosing which person goes into which group. It's just random. So we have 12. I mean, Derek, I don't know if you want to stay back, you can. But we have 11 students and then,
Thanks a lot for
so maybe 3 groups, yeah. So let's go then. Just remember your room number, and I'm hoping you have all taken down the questions from the chat. So, all right then. Good luck, everyone. And see you in just a while.
Eso querían,
All right, so then let's see. From the breakout room number 1, the group 1 was David, Chen, David, Robert, and Roya. And you had to write a function for the S-linked list class to find a given element. So how far were you able to write the function?
We got pretty far, I'd say. I think we almost finished it, if not.
So anyone wants to share the screen or you want to post it in the chat, the code?
It would take a second, but
I think 7 or 8 is cool. Yeah. It's quite like
Okay.
more than what I need on the mission.
So this is the code for finding the element. So I'm just taking this code and I'm copying it from the chat, and then let me share the screen. So this is the S-link list HPP, and over here, right after the traverse function, I'm copying the group one's code over here. So find element. Okay, so we need to have a this header also in the HPP. So let me get this here. Okay. So you have the node star pointer, which is correct. Setting the pointer to head, correct. And you set as you have a while loop, and you see whether it's going to null or not. And until then, you're printing out the data just for error checking, right? For some reason,
Just for internet, yeah.
right? That's why you're printing it out.
No, we use the we kind of just copy and pasted the traverse
Yeah, that's fine.
and then made the changes. But by the time we got that far, it was kind of just like going in just trying to get it out there before we could kind of streamline it.
No, but it's totally fine. It's fine that you started with the traverse function, which is actually a good thing to do, because that you are technically traversing the list and trying to do something. So that's fine, totally fine. Let me just comment this out. We are not printing it out now. So you're checking if pointers data is equal to element, which is correct. Return 1, and then otherwise just go to next. And then inside you're doing, in the same while loop, you're doing if pointer is equal to null pointer, return 0. So far the logic is good up until here. The logic is good. That's what you had to do. But over here, when you're trying to actually, the pointer will never be null pointer, because the while only enters when the pointer is not null pointer, right? So inside the while, the pointer can never be null pointer. Do you see what I'm saying?
Yeah, that makes sense. This is kind of like we started running out of time at this point, so
Right.
yeah.
So the only thing that you had to do is, once the idea was that if it was ever found, then it would just simply, the function will return 1 and exit, right? The return just exits the function. Otherwise, it will keep going pointer equals pointer next until it finds this thing. But eventually, if it did not find, it will still run over the entire loop. So technically, it will get out of the while loop and reach here. The pointer is equal to null pointer eventually will make it get out of the while loop. That would technically be the end of the list. So you would not be doing pointer equals to null pointer eventually. You will simply be doing return 0 outside the while loop.
Cool.
Because,
Hi, does this help you?
yeah, go ahead.
Yeah, this is William again.
I was just saying, like,
You know,
cool.
your son,
Good to know.
when
Thank
he
you for
comes in
that.
tomorrow, can
Right.
you help to bring in his?
Right. So
if he
because
wants to have-
if it was any time found in the list, that would just activate this
Okay.
and return 1 and get out of the function. If it was not found, say at the first place, this will move it to the second, then to the third, and so on. But if it was never found, so this will never be activated, then eventually it will exit the while loop and pointer will be null. And then over here, you just return 0. So one more thing over here is, since you're returning something, it cannot be void over here, because this one is returning something. So it cannot be void. It will actually have the type of the item you're trying to return. And what are you trying to return? It's like an int, really, because it's either 0 or 1. But because we always use the size t, which also like reflects something positive, it just reflects, the indexes, the counts. But size t is always positive, so or 0. So you are returning 0 or 1. So just use size t. instead of the int, but not void. And also fix the void over here in the HPP, where you will have size t. And then in here also, it's a templated class where the type name is data _t, which means that for our example, we have used integers, but it could very well be double. It could be anything. But that we are defining in the main function. In the hxx, you just use a placeholder because it's a templated class, and that would just be data t. Right? And so we will also have to fix this one here. This is data t.
You know that? I saw that on the internet. Somebody was like, oh, look at your Amazon thing.
So now we can try to run this function on our list to see what the answer we get. So this is our list currently. First, let's see what we have in the list. This is a list 13, 13, 4, 9, 13, 10. So if we are trying to search for, and it will either return 1 or 0. So we'll have it printed out. So in what we are trying to print, I'll call the function, which is find element. So let me try to, and it needs to, because it needs to take in the argument what you're trying to find. So maybe you're trying to find 13 in the list. And 13 does occur in the list 3 times, but even one occurrence, because you're just finding out whether it is there or not. So it should print out 1. So there you go. Right? Then you can also test for 4.
Wait, that's why they didn't give you the phone?
No. So it's
That should also have 1.
Oh, they put it on the other line?
Then you can also test for 10. Also has 1, meaning all these are found. But now we can try to test for 3. 3 doesn't occur in the list. So that should print out 0. So there you go. So is it clear, everyone?
Can I ask a question? Can we ask for multiple number to see if it's in the element or not? Like maybe 3 or 10 at the same time?
Not at the same time. It's because the function is written like this.
Oh,
Function is only taking in one element. Now, if you were to write another function where it's taking in like a list of elements over here, maybe like a vector of elements over here, then the code for the function will also change, right? Because you have to test for each element, right? But you can. I mean, that function can also be written. It's just not this function. But if you want to write that function, then you have to change this, that you're taking in like a vector of elements over here. Then 3, 4, 10, you're passing over here. But then that while loop would have to be run for each of the lists. So basically you will have like a while loop inside a for loop. And technically you are just going over the list for the entire list, but for each element. So it's basically a while loop inside a while loop. You see what I'm saying?
yes.
Okay. Okay. So, all right. Good job, group 1. You were close to the logic, right? So, all right. I'll be also posting this code later on for everyone to refer to. But now let's go to group number 2, which had to do the same thing for the given element, finding it, but to do it in a doubly linked, and doubly linked was little bit different than singly linked list. So let's see, the group people were AD, Andrew, Eric, and Matthew.
Yeah, so we Here, let me show my screen. We did a similar thing. In fact, it's like the exact same thing, except for it's in the I don't know. We went down this weird route initially with iterators, and then we went down a route with pointers.
You could also have used the iterators. That's good too. I mean, you could use either of them.
So, and then I realized we put our code initially in
But I still
the
wouldn't, oh, right?
delinked list implementation file. So I accidentally have two of them here because I realized we wanted it in the dummy node
Yeah.
delinked. So in the HPP file, where did we put it? Oh, it's right here. So here's the function implementation, or just the not the implementation, just the header.
Yeah.
And so it takes an element, and then I initially put it in the delinked list, and I just copied this code over to the dummy node.
I just have like receipts and
Okay.
and online
So
payment logs,
it's a
like
bool,
Venmo.
delinked list, and then it's a data. It takes in whatever type it is as an element, and then I updated it to do a similar approach with the pointer and the pointer going to the head. Initially, what we had was an iterator. We declared a new iterator and used the front function to set it to the front, but I had no clue how to transverse that. So
Okay.
yeah, so I went with this way because it just bothered me that head didn't like change color or something. So I felt like it wasn't in the file. And so I was looking around for that because I see it being used other places.
But so
but then yeah,
right, and then that should be instead of the IT, it should be PTR.
Is it? Oh yeah.
yeah.
So everything is fine. Only thing is now you're using dummy nodes. So should it still be pointer equals to just head, or it's dummy nodes? So head is pointing to the first dummy node, right? The list technically does not begin from there.
It begins at the
So mostly, I can actually annotate on the screen. So if it's a dummy node linked list, that means that currently, if this is the list, so 1, 13, and then 10, and this is so these are two dummy nodes, dummy 1, dummy 2, and this is a doubly linked list, so you have these as well. So the head, when you set this one here, pointer equals head, head is currently pointing to the dummy 1, and tail is pointing to the dummy 2. So my question is, when you set the pointer to head over here, you start checking the pointer's data, but technically this is not a part of the list. It's just a dummy.
So it should be head
Head's
pointer
next.
next.
Yes. That's the difference that was supposed to be between the singly linked list and the doubly linked list. And that's what I said, that it would be slightly different if you use, because you were to use the dummy node linked list, dummy node implementation.
All right.
And then the pointer will also be checking until, not the null pointer, but just the tail, right?
Oh yeah, we can go there.
While the line 54,
You can pick your team.
right. So those two, not the pointer's tail, no, just the tail.
Just tail.
Yeah, it's able to get the tail because this is a part of the same class. And how you're able to get head directly, you're able to get the tail directly as well. right?
No, she pays the water.
Because it's a member variable, right?
It's a member
The
variable, yes.
electricity here, they get you because they put the trash can fee. And they charge you like.
So
50
basically, the thing is that the struct has, this is the struct has the data
bucks. On the DWP, it has the trash can fee.
and the
They cobran like
next
50
two things inside the struct. So if the pointer is a pointer to the struct, that's why you had to do PTR pointer data and you do a PTR pointer next. But only these two things are part of the structure. The head and tail are not a part of the structure. So head doesn't need
No, but
a
why is
pointer
it-
arrow head or a pointer arrow. They are outside of the struct. So head is here. That's what it means. Head itself can directly get heads data and heads next, but you don't have to do pointers, arrow to head, and this pointer is directly pointing to a structure. A pointer is not pointing to a pointer. So pointer, tail is a pointer. So that's why you just had to do underscore tail.
How much do you spend on
But the
food?
whole point is this is dummy node. That's why the difference from the singly linked list is you're doing heads next instead of just head, because this node is just a dummy. You really begin the list from here. That's why you're setting the pointer to heads next over here.
The what?
And then you keep going next until your next reaches the tail, which is again a dummy,
I don't have
technically
to touch,
signifying the
sorry.
end of the
I
list.
can't make them like Tita. And
So is that
Tita le
clear?
pela el pomegranate. Like,
Yeah, that makes
every
sense.
little piece of the saca.
Alright. So this is, all right, I just cleared my drawings. All right, so if, as you can stop sharing if you like.
Is that like 300 bucks?
So that's good then,
This doesn't
group
mean
two
all the stuff
also.
we need during lunchtime?
And then you have group three, which was a different question, was to
For 300 bucks?
return the number of elements in the list. So you had to count totally how many elements were there in the list for a singly linked list.
And then find it, right?
Okay. Let me. Hmm. I can't share my screen for some reason,
I could have wrote a message.
but
Yes, I know.
basically this is the function we wrote.
Tax office.
Oh, no.
Okay, this is the function.
Doing pretty good.
So then should I just copy and paste this in my singly linked list implementation?
Okay. I know it's on a W2, you have a different
Yes,
address.
You can, I will share my screen and then you can actually talk about it. So this is the function list, my HXX. I'll just copy your function over here.
All right, so
And now you can talk about it.
the things are pretty much the same.
One thing that we have to do, because we want to test this, so we will
Exactly.
then
You still
have a
the
template.
address that,
We have, if we have to run this, so we'll have the template. Then another thing is that you have to have the name of the class before the name of the function.
Yes,
You have to have this.
I had it written in the HPP. I know. That's why I forgot all that stuff.
Another thing is, like, we always use size t instead of just int.
Oh, okay.
It's a positive integer, so you can, and let me copy this header in my HPP. I don't need the class name because this is inside the class definition. All right, so go ahead then.
We also have to change line 325 to a size T.
Oh, to a size T, okay.
No me quiero hacer ilusiones until it's real.
All right.
I need some place.
So basically, we just set up a current pointer to a node on line 324. which points to the class head. Then we start a counter. We look through
Mine does the same thing.
the nodes. So basically, we just get the current count, the current node, and then we move to the next node, and we keep looping until we hit the last node, which is supposed to be a null pointer.
Computer,
Right.
And return the count.
Right. So basically, you are just going over each node, like traversing the list, and you're also incrementing the count every time, because as long as it is not null, it is keep adding that next node, right?
Yeah.
So one thing I want to ask is, why did you use this pointer head?
Okay. When was actually come down?
Why did I use these head?
This keyword.
The keyword. Force of habit. I know it's basically, I could have not used it.
Right.
I'm just used to it.
Oh, you're just used to it. Okay, that's fine. If anybody else is confused in the class, we can also not use this. The thing is that this head is directly available in the class itself. You can see this head is directly available in the class itself. So any of the functions in the class, which is just including the latest one that we have written, any function in the class can get access to this private data member because it's a member of the class. So all the functions are able to use head straight away. So using this is an implicit pointer, meaning it's always there. Implicit meaning it's sort of invisible. It's still there, but even if you use it, that's fine. But if you don't use it, that's also fine. It's just a programming practice. The point over here is that this code is correct. You're checking as long as it's not null pointer. You increment because you're on that node, and then you go next, and then you again go to increment, and you keep counting. Just how you were printing, just how you were searching element by element, you're counting element by element. Now return count plus plus. Why did you do count plus plus over here?
That was my bad. No, I shouldn't have put it plus plus. I should have just returned count.
Just count, right? Just count.
Yeah,
So,
because the plus one would increment the count.
right. So let us just then try to run this function over here. So I will put a blank line and then try to print out the result of this. This function is called get nodes count. We should be able to just write this, get this function, just double click to. And now I want to suppose search 13 is the element I'm getting the count for. You can see that, okay, get nodes. Oh, you're just not finding it anymore. You're just finding the number of the elements. I forgot. Just counting the total number of elements in the list. So let's run this. So you have 13, 13, 4, 9, 13, 10. So you have 6 elements, and which is correct. So total 6 elements, it's counting it correctly. You can also try to change your list. Just comment out a couple of lines. Now you have 4 elements.
Yeah.
Let's run this again.
No.
Now you have 4 elements,
And we weren't
right?
that far. We're like in Barranca.
All right, so this is good. I mean, overall, everyone has done well for these activities. So let me now, do you have any questions?
So what?
So hopefully you have a good idea now how to address the homework questions. So this was what this homework for is, so the function goal is different in 5 and 6. You had to do something else, but now you know basically how Those functions are written.
Like the sprinkler?
And if
ones
you
or
want to
the
test
ones on the
them,
rock?
how would you go about testing them?
Oh, so.
Now, once you have written these functions and you have tested them like how we just tested them over here, once you have tested them, just use the sample data, the sample program, try to change your list by adding or deleting more nodes and by checking for various possibilities. Once you're satisfied with that, you can just simply, you can add it in the HXX to run it and see and everything. But once you're done, you can simply copy this code, simply copy this code, and then, just use a text editor or your, the Word file, for example, you can just simply paste that code over here. And when you're submitting, so when you're submitting the final Word document, your running function that you have, just copy and paste it onto the final file you're submitting. So you don't need to submit the entire .cpp file or the entire .hxx file. You just need to submit this function. It is for your own satisfaction that you can actually run it and see whether it runs and produces the correct result. Right?
Oh, Anthony, good work.
And so similar to what we have seen, the tasks that we have seen today, similar to the homework questions, you will also get a coding question in the midterm exam, which would be very similar to ones you have seen. So it will say that add a function either to the, the exam would say that, but the question could be wanting you to add either to the singly linked list class or to the doubly linked list class. But exactly what we have seen. And then the function's goal would be obviously something, some question it will have. But now you know basically how to go about it. Right? So now, do you have any questions? Did everyone understand all of these functions? So no questions at all? All right. So then that's about it. Then I will be posting this code today. I'll be sending an announcement after I've done that. So just remember to review that code.
Like around the thing on the side, yeah.
All right, so let's wrap up then and meet again on Thursday, okay? All right, so bye everyone.